right, guys, so I got one question from...
Chapter 11, 21, page 678. We're number 15.
All right, guys, so I have a question from section 11.1, number 15. So this was the 3x3.
I have one quick question. Are you going to be adding more homework to the minor math lab, or that's it? Like for the minor math lab, because there's only like 3 or 4 assignments. I just want to know if those are all for this whole until the next test. So
if you're doing the online homework, I better put the ones up there that you need for the test.
Did you put 7.1, I think 7.2, and like 11 or 10?
Yes.
So those all of them?
What do you mean it's all of them?
He's asking if you only have to do chapter 7, 7.1, 7.2, and 11 for the next test, or if you're going to add.
Yeah, I just added another section, for example, from what we're going to go over today. So I'm going to keep adding. Yeah. So you got the homework sheet. You know exactly how much homework there is until the next test. So, yeah, I better put that up there so you guys have a chance to practice. So number 15. Let's begin a little review. Now there's actually a really quick, that's really interesting. Oh, it's 2y. Okay, I was going to say. That's a little too quick right there. There's a semi-quick, there's something interesting that you could do. And this doesn't happen all the time. Does anybody see something interesting? Since our whole purpose is to kill variables, what's kind of nice about this problem? Yeah, if I did 1 and 3, what happens? The x and the z's die. Then I'll know what y is. And actually, the first time you see that, you get a little freaked out. You're like, all right, okay. What do I do with that? So what's really beautiful about that, so I don't know what you tried, Judy, but do you see how if you add 1 and 3 together? Yeah, so what do you get? The fourth equation will be, that's gone, negative y, that's gone, equals 1. So then y is... Divided by negative 1, y is negative 1. Now here's what's really cool about when that happens. Now I can go back and choose any two of these and put negative 1 in for y, and I'll have two equations with x and z in it. Maybe don't pick 1 and 3, right? I don't know if you guys see why not. So maybe I could pick 1 and 2. I know y is negative 1, so how can I write number 1 now? Yeah, x minus 1 plus z equals 0, so x plus z equals 1. That's what equation number 1 becomes. And what does equation number 2 become? Careful, so 3y and y is negative 1, so it'll be minus 3 plus 2z equals negative 3. So I get, if I add 3 over, I get 2x plus 2z equals 0. So then I actually get what? What can I do with that? That's a z, sorry. I can divide by 2, for example, right? Alright, how do you go so far? So that, now what's about to happen isn't always going to happen when this thing happens. But when this thing happens, that's exactly what you do. You plug it back into a couple of these, that kicks so much ass. It's that much quicker to get your two equations with 2 letters in it. Now what additional weirdness just happened? Does anybody see what's going to happen between these two?
Both variables are going to go.
Yeah, but take this one and multiply by what? Yeah, if I multiply by negative 1, I'll get negative x minus z equals negative 1. So I get 0 equals negative 1, which means...
False.
Even better.
Okay.
Right. My answer's got to be the solution, so it's either going to be a point, or it's going to be the phrase no solution. Cool. So in this case, that could never be true. No solution. So visually, these are two planes that are like sitting next to each other with a third plane coming in somehow. So they don't still all meet at one point. Does that make sense? I mean, that's what's happening geometrically. I don't want to graph 3D planes, but you can kind of imagine it would be like the floor and the ceiling, and then the side. They don't all meet at one point, do they? These guys don't meet. They hit that guy, but they don't all agree on one point. Not like the ceiling and that wall and this wall. They all agree on that point there, right? That would be x equals y equals z equals. This is if I have two parallel to each other, or they all kind of, none of them, they don't all meet at one place. That's the problem. Okay, good. So it doesn't mean necessarily you're doing something wrong if you get that. That's actually an answer. No solution. Yeah?
If you get that, how do you check to make sure that you just didn't mess up?
Redo it. So it's different. It's easy to check if you get an answer. You just plug it back in. It's almost impossible to check if you get no solution. To check that, you would try every possible set of 3 numbers and put them in there. No, I feel like that. Yeah. So you just double check and make sure you didn't screw something up. That's the best you could do for this. Yeah. Kind of sucks. It's hard to check no solution. Because the only way to check it is to actually show that nothing works, which means you have to try everything. I'm not going to do that. Yeah. You guys have the weirdest look. Sure, Jeff. All right. Anything else from homework?
I have one.
Yeah.
But it's from 7.1.
Okay.
It's number 55.
Oh yeah, good. All right. So what we just got into was if I see something, let me kind of work my way towards that. If I see something like this, what would that be? 1. It's just 1, right? Something divided by itself is 1. So if I see this, it can't be 1 because it's not something divided by itself. So it is definitely not 1. Right?
Doesn't that mean it's the same? That is an exact identical. 2 minus x and x minus 2.
What if x is 5? What number is that? 3. What number is that? Negative 3. So the division would be negative 1. Now, the way to show it is what can come out of the bottom, for example. What can you take out of it? Negative 1. And what are you left with? The x becomes positive, and the 2 becomes, those cancel. So you're left with 1 over negative 1, which is negative 1. So something divided by the exact opposite of that thing is going to divide to be negative 1. Well, we know that. 6 divided by negative 6 is negative 1. Just looks freakier when you have these. Now, the actual question I got, now, whoever asked the question, you now know what the answer is. That pretty much gives it away. But it looks like this. This is number 55 in 7.1. Yeah. So you can save yourself a lot of hassle. You can start to factor the stuff. And you actually can factor it, and it's a difference of squares and all kind of stuff. But notice that the bottom is the exact opposite of the top. So when they divide, you'll be left with negative 1. Cool. You could take a negative 1 out of the top, and what are you left with? The negative 28 becomes positive 28, because you took a negative out. And the positive 7s squared becomes negative 7s squared, which is exactly what's on the bottom. So these cancel.
So Jeff, why do you start from left to the right when you divide minus 1 divided by 28? I mean, why you don't start at like 7s minus 28? on the top.
You mean here?
Yeah. Why you started like
Okay,
the
so
left to the
if I
right.
took a -1 out, the 7 would become negative S7S squared, right? And the negative 28 would become positive 28. I was just putting the positive term first. That's all. Yeah.
Can you take the 7 instead of the -1? Would you just be able to do the 7?
You know, do
Well,
what?
I'm talking about, right?
You can take a 7 out, is that what you're saying?
Yes.
Sure, you could.
Okay.
You don't need to. Just because these are trying to be the same, they're just offset by a negative. So if you take a negative out, you're left with exactly the same stuff, and those would cancel, right? So if I had some long, disgusting thing that you had to factor, and and then divided by the same damn thing, I wouldn't factor anything. I would just kill it. This is just one more step. If it's almost the same damn thing, if just all the signs are reversed, you could just take a -1 out and then kill the whole thing. You don't have to do any factoring. Right? So if I said reduce 820 over 484, that would kind of suck, right? But if I said reduce 820 over negative 820, you're not going to factor those, right? You're just -1. I got no work to do. So the exact same thing happens with expressions. Now, if you didn't notice it and you just start to factor things, it'll still work in the end. It's just going to be a little longer than it should have been. Okay? So anything else from the homework? It's a strange day already.
When you say to check it, because it says like check it with an example 6, but in the example, it's a fraction. So you just pick any number and you try it with the initial equation, the initial thing that
Oh wow! I never noticed that they actually do my thing. I like it. Huh? Sorry. Yeah. So what's the matter? So yeah, just choose a number for S and T. Yeah, and then just see if it works out. Yeah. So you could choose 1 for both of them. That would make it quick. If I choose 1 for both of them, that's 7 times 1 minus 28 times 1. 7 minus 28 is negative 21. 28 minus 7 is positive 21. They divide to be negative 1. Kick-ass.
I have one more question, and it's back on 11.1.
Yeah.
Number 20,
Number
21.
21? So what's going on with that one? Did it come out weird? Let's see.
Well, that was the one, the answer was dependent on the middle equation.
Okay.
So I just wanted to see what worked that out.
Done. Mix and match 2 of them up. Which one? Looking at 21?
Yes.
Mix minus 2y plus c equals 0. Alright. Yeah. Alright. So what can you do? Where do you start? What do you try to do? What do you do first?
23?
Huh?
23?
So between these two, what would happen?
Multiply
What's
or
one
go
and
right.
three?
Negative.
Hey, real quick, notice number 1. I was waiting to see if anybody would say this. Have you seen anything about number 1? Equation number 1? Yeah, you can divide all of them by 2, right? Do you guys see that? If you wanted to. Doesn't really matter. The way it's set up now, if I divided them all by 2, these would die. Do you see that? Right? And then I could just multiply this by 3 and it would kill this. That would be, to me, the quickest way to do something. You guys? So if I took number 1 and I just cut them all down by 2, and I'm totally allowed to do that because I've just got an equation that I'm dividing both sides by 2. Right? So now between these two, if I add 1 and 2, I get 4. My fourth equation. What do I get when I add these together? 0
Plus 10y
10y
plus 4z
plus 4z
equals
6. Okay. So far everything looks good, right? And what do I have to do now? Choose another one, another pair, and
3 and 1.
yeah, I would do these two, right? Because I want it. What do I want to kill? I have to kill the x again. So whatever I kill first, I want to kill it again. Okay. I just always want my dean to walk in right then. If you kill it, and whatever you kill, you're going to kill it again. And what the hell are you teaching there? So between 3 and 1, if I take 3, and I take 1 and I multiply 1 by 3.
Minus 3.
And see, this is a really good example of a problem where you just got to focus on the only thing important to you right now. There's a lot of shit up on the board, right? But the only thing I care about right now is killing an x. So right now, my whole world is this at the moment. And I go, okay, if only there was a 3 there. So then I multiply this by 3. So now I'm just looking at this piece. Is that cool? Just multiply that by 3. Is that cool?
Mm-hmm.
I have people with concerned faces. You have to speak up.
Does that turn into equation 5?
It will, exactly. So I took equation number 1 and multiplied it by 3 so that these two would kill each other. So now I'm going to let them kill each other. What do I get there? 10y plus 4z equals 6. Now what do you notice?
They're the same.
They're the same. So if you try to between these two, and notice I got that equation from 1 and 2. I got this equation from 1 and 3. They're the same, aren't they? They're the same. So if I take equation number 4, how would I kill the y's?
Multiply by negative.
Multiply by negative 1. It's almost silly to do that, but let's do it. I get negative 10y minus 4z equals negative 6, so I get 0 equals 0. Now, I always have somebody tell me y equals 0 or something. Is there a y alive? No, all the letters die. Let them die. I get 0 equals 0. That's the opposite of 1 equals 0 or something like that. That would mean no solution. What does 0 equals 0 mean? Don't say all real numbers, because we know it's not numbers that are answers here. Answers here are points. So a few ways you can answer this is an infinite number of points. But don't say all real numbers. It doesn't make any sense, because the answer to this would be points. So there must be an infinite number of points that answer this. So again, if I had 3 planes, okay, let's see how this works. If I had 3 planes that came together like that, you guys can't see that, but I won't do it. So if I had 3 planes that came together, they met like this. See that? See, how do those planes meet? They meet at a line, just like these 2 planes here. They meet at the line there, right? So if I had another plane that came in, like this paper, came in and met along the same line, the answer would be the line. Well, how many points are on that line? Infinite number of points. Right? That's one way to have an infinite number of answers. And that's how to tell when you're in that situation, you have a true statement. So that must mean there's a lot of answers. In this case, there's an infinite number of points that are answers. Like if 0 equals 1, that means the planes aren't hitting each other in the right place. They're not agreeing on one spot. So then there's no solution.
Is that section 7.1?
That was 11.1. Yeah. Yeah, we're bouncing between the two. So anything else from homework? All right, I'll take that as a no. Okay. We're going to keep going in chapter 7. So last time we got up through 7.2, believe it or not. Let's just do a couple of problems there. Just remember what the heck we did. And this is where you start to realize how important factoring is. So here, you guys try this here. Oh, what you guys are fine. Alright, that looks yummy. Yeah, make this a -6x. All right. Just remember, how do you divide fractions? Multiply by the reciprocal of the second dude. So division is the same thing as multiplication. So if you know factoring, this should be pretty simple. It's just one extra step, and it's a very satisfying step. It's always nice when you can kill parts of an algebraic equation, just kill it. So how do you factor this here?
X minus 3.
And I hope to God nobody tried to kill the x squares, right? Why can't you do that? Division is not the opposite of subtraction. You can't break into a subtraction or addition problem with division. It's just not that powerful. So if I had x, y over x, I could totally do that all day long because the division would cancel that multiplication. But the minute I make it x minus y over x, hell no. No way. Because division does not cancel subtraction. How would I kill the x? I'd have to subtract the x because it's a positive x, right? I can't just divide the x away. That's not going to work. I can't cancel it that way. Okay. So I do this, you guys said x minus 1, x minus 3.
X plus 3, X minus 3.
Let me see you guys. So if I multiply by the reciprocal, how do you factor this?
1, X, 1,
X plus 1.
Yeah, those of you who try to do it like this, never going to work. Right? There's not 3 terms there. And what do you always try first?
GCF.
Yeah, GCF will save your ass. So always try GCF first. Right? GCF has your back. How do you do this guy?
X minus 9, X plus 3.
Yeah, x minus 9,
9x.
x plus 3, big one, negative. I like it. And now you just go to town. Now you just let out some of your frustrations with math and just kill pieces of math. X minus 3 dies. What else?
X plus 3.
Yeah, x plus 3 dies. X minus 1 dies. So what's left alive?
X minus 9 over X.
Good. So notice the only way it could die is if part of it's on top and part of it's somewhere on the bottom, right? So I can kill them when they're one on top of each other. I can kill them when one's there and the other one's down there. But if they're across from each other, hell no. They're multiplying across. They're not going to cancel in. They're going to multiply each other. Does that make sense? They can only be up top and down below. That's true division. Then they will cancel each other out. So for example, if I had a problem that I factored and I got to this point here. What point, Jeff? I don't know. Give me a second. What can you do?
Kill the X plus.
Yeah, x plus 2 is definitely go up. What else?
X minus 1 is don't go up.
Good! You had me scared for a second, then you saved it.
Because they're across.
They're across from each other. Yes?
On the last problem, I got the same problem, but just switched. Like x parentheses x minus 1 is on my top.
Oh, well, it was a division problem,
So
right?
I had to switch.
You have to multiply by the reciprocal. That's the only way we have to divide fractions. There are other ways, but you have to be really organized in where things go. This is the easiest way to make sure everything ends up in the right place.
Yeah, because I got x over x minus 9, and that would be wrong. Because it's x minus 9.
Yeah, because then things would have been in the wrong place here to cancel. Yeah. Here, what's my actual answer?
X minus 1
X minus 1 squared.
Kick ass. I like it. Good. So be real careful. It's really simple. Our brains just get totally into killing things, and you just can't kill them if they're across from each other. All right? Math psychos. Yes?
If we were to have say the x plus 2 is an example, do they cancel? And your final answer was x plus 2, x minus 1. When we write it as the answer, and it was over x, do we actually
No.
we just
Don't
leave it
FOIL them
as
back
x?
out. Leave them factored. Yeah.
Okay,
Don't FOIL them back out. Don't waste your time doing that.
okay,
Leave them factored because then you can make sure that nothing else cancels.
right.
Yeah. Cool. Okay. Not too bad, right? If you can factor, most of the section, most of the chapter should be decently easy. If you can't factor, it's going to be next to impossible, right? So it's kind of a huge split there. So normally the quizzes are a bunch of A's and a bunch of F's. It all depends on if you know what you're doing. So let's take this next step. That was ominous, Jeff, I know, but this is the truth. So the next step is now we know all the way through, multiplying, dividing, but now we got to go back and look at adding, subtracting. What happens there? Now, with fractions, with numbers in fractions, just numbers, if I have 1/2 plus 1/4, what do I have to be careful about? Is that 2/6?
No.
Looks good. 2/6. Yay, it's easy.
You have to put in on
1 6.
Common denominator.
You need a common denominator. And the whole reason you need a common denominator is the same reason I can add x and 2x, but I can't add x and 2y. So here I have 1/2 and 1/4. It's like 1x plus 1y. They're not like terms. I need like terms when I add and subtract. I don't really need like terms when I multiply or divide. That's why I don't need to get an LCD when I multiply or divide. So if I had 1/2 times 1/4, that's easy. What's that? 1/8. Done. You don't need like terms when you multiply. What's x plus x squared?
X plus X squared.
Oh, no.
It's x plus x squared. There are no like terms there, right? You can only add or subtract like terms. But what's x times x squared? Yeah, I don't care that they're not like terms. They have the same base, so I can put them together. So multiplication division, not nearly as restrictive. You don't have to have like terms. That's why with the whole last section, I didn't make the LCDs the same. Because the whole point is to kill things. And how do I make LCD the same? I give them stuff. No, I'm trying to kill stuff. But when I'm trying to add or subtract, I can't add or subtract them unless they are the same term, the like terms. This is 1/2, and this is 1/4. They're not like terms. But with this, of course, what can I do?
Times
Else.
Yeah, what does this need?
times
2. So I have a 2/4 plus 1/4, 3/4. Yay! All right, cool. This is just like 1x plus 2x is, what's 1x plus 2x? 3x. So 1/4 plus 2/4 is 3/4. So don't make it over 8. Don't tell me that. That's horrible. You keep adding things together and keep getting smaller. What the hell? You keep working and the amount of money you get is less. What? No, I want to get bigger when I add things together. Alright, so that's numbers. Numbers are nice. So let's come to the numbers I don't know. The variable expressions. How the hell do we do those? So let's kind of build up to it. If I had 5 7s plus 3 7s, that is
8
8 7s. If I had 5 11s plus 3 11s, that is 8 11s. If I had 5 over t plus 3 over t, that is 8 over t. I love it. Because they have the same denominator, right? It doesn't matter that it's t. If it's 7, it's this problem. If it's 11, it's this problem. But what is it? T, okay, so it's 8 over whatever the hell t is. Because they both have the same denominator. How we doing so far? Of course, this might be some old news to some of us, but I just want to make sure we're all on the same page. So if they're already like denominators, let that be easy. The only thing you have to be careful about, so you know going into this problem, there's something to be careful about, is if you have something like this. There's one little thing to be careful about.
It has a common denominator.
Good, so it's got a common denominator, so maybe I'm
2x minus 2.
I love it, cool, I agree. It's totally 2x minus 2 over x minus 1. That looks good so far. What you always have to do at the end of a problem, you have to make sure the fraction doesn't reduce. And this one will reduce. What comes out of the top? 2. And what's left? So what happens? So you get 2. So it's kind of neat. Think about what it says. No matter what you make x, the fractions you get from that will become 2 when you subtract this. No matter what you put in for x, of course, except for what? What value cannot go in for x? 1. See that? That makes the bottom 0. I can't divide by 0, right? So I can't use 1. But give me any other number. 5. It's the first one I heard. So if x is 5, this problem is done, right? This is Jeff's weird thing he does. So if x is 5, what do I have here? What's that first fraction going to be? 10 over 4 minus 2 over 4, right? Is that cool? X is 5. So that's 4, that's 4, this is 10. What's 10 fourths minus 2 fourths? 8 over 4, which is 2. That's what it said it was going to be, right? It says no matter what you pick for x, the answer is going to come out to be 2. That's a little bit neat, right? Some of you guys hopefully agree. It's a little bit neat. Some of you guys are going to just say yes just to make me feel better. That's all right. That's fine. Okay. So that's really nice when the bottoms are already the same. The one thing you've got to be careful about, always, even if bottoms are not the same, is at the end, just see if you can factor anything, if anything will cancel. It's the same thing you did when you had regular fractions, right? When you had, what's 11 over 21 plus 4 over 21? And if you give me that as an answer, I would take points off, right? Because you can reduce it. So if anything that happens with numbers has to also happen with variable expressions because they are just numbers that don't know. I know I've said that a lot, but it's important to get that down. So here I could divide by 3. Or even better, 15 is 5 times 3, 21 is 7 times 3. So that looks a lot like what we were doing right there where they cancel the common factors. Cool. Okay. So, what if we have a situation where the bottoms are not the same? Let me see all that stuff. Good, okay, good. So 7-3 is all about, they already have like denominators. So the hardest 7-3 could get is it have some freaky factoring method that you'd have to use. So for example, if I had, let's see if I can make this up on the fly. If I had y cubed minus y over, y minus 2 plus y minus 8 over y minus 2. That looks good. All right, let's see what happens. What happens there?
You factor the top first.
You could, it's just not going to go anywhere. You see that? You could take a y out, but then it'd be y squared minus 1, which is not going to cancel with this, right? So there's no real reason. Yeah, they already have like denominators. But it's not a bad idea to check first, but they already have LCD, so I probably don't want to mess with that. So what do I get when I add these?
Y cubed.
Minus y plus y.
Cancel.
So you get minus 8 over y minus 2, and if you stop there, you're going to lose points. What can you do from there?
The exact one.
Factor. Good. But 8 divided by 2 is 4. Right?
But you can't do.
Thank you. Good. I like it. I'm glad that some of you guys are like, don't do that. I'm like, good. You can't use division to break into a subtraction problem. You cannot. So you have to factor in. Of course, what form is the top end?
Cube.
One of our favorite forms. So I got little dude, big dude. Y cubed minus 8. Y. 2, 2, 2. What goes in the little dude?
Y.
Y minus 2, that's not surprising. What goes in the big dude?
Y.
Y squared. At the end is 4. In the middle, what sign? Plus. It's got to be the cancellation term, right? Plus 2y. So then, of course, what cancels?
1.
Yeah, y minus 2. So your answer is that. So that is going to be the hard part on 7-3, is just when you get to what you think the answer is, you got to take one more step. You got to see if anything factors and cancels. You good
I
with
was going to say, for me, I thought that could be factored too, but I don't think you can.
the big dude will never factor. Don't waste any time on the big dude from a cubes. He will never factor. Yeah, leave him alone. Don't take this as a challenge. Just understand that is the truth. If the big dude's always, if you double the middle of the big dude, it's instantly factorable. The middle term is half of what it needs to be factorable. So the big dude is never factorable. Cool. Okay. All right. So what do I do if the denominators are not the same? So it's really overanalyze, and I'll show you a neat way to do it with numbers. Let me give you kind of an ugly number example here.
Is it 7-4?
Yeah.
This is 7.4.
Yes, 7-4. Oh, let's see what you got, Jeff. All right, that is just yummy. So here's a cool way to do this if the bottoms are disgusting, right? Not yummy how I describe it. It's not many people would, except for me. 54. What do 54 and 30 have in common? What's the biggest number?
6.
They have 6 in common. That's the biggest number they have in common, right? So what is 54? 6 times?
9.
Yes, good. 6 times 8 is 48. Not enough 6s. Need 9 6s. 30 is 6 times 5. Good. So then you can just give each one of them what they're missing compared to the other dude. What is the bottom of this guy missing that he's got? 5. So you multiply by 5. Right? 36 times 9. So what is he missing that he's got?
9.
9. So now they both have the same bottom, don't they? Whatever 5 times 6 times 9 is. And what is 5 times 6 times 9? 5 times 6 is
36.
times 9 is 270. Good. So this will be what over 270? 55 over 270 plus 63 over 270.
Plus 60 is 118.
118 over 270. Which you can at least reduce by doing what?
Divided by 2.
Yeah, they're both even, so you can divide by 2. How are we doing so far? Are we good?
Yeah.
I really like to show that. I show that to my Math 88 students because it helps when we get to this point, when we start doing with variable expressions down here, you want to look at it exactly like this. You break them up and you give each one what the other guy's got that they're missing. It's kind of like if you have little kids. He's got more ice cream. Okay, here's a little more ice cream. Now you get the same amount of ice cream. Right? So divide by 2, what do you get?
59 over 135.
Good. And that looks pretty good. Not too much goes into 59. I don't think anything goes into 59. All right, how are we doing so far? And that's old news, but you normally didn't work with numbers like that, but that's one way to kind of approach it. Figure out what the biggest thing they have in common is, and then whatever they multiply by, that's what the other dude's missing. That's what you give them, right? Don't just give him a 54. Shit, then your numbers get huge. He only needed a 9. Okay. So, what about if there's variable expressions in there? So what if I have, what you got? X over x squared minus 4 plus 3 over x squared plus 4x minus 12. I like it. I like it a lot.
You multiply each by the little?
Not yet.
You first have to factor?
You first factor so you can see what they're made of. What's the first thing we did over there? We factored, right? Difference here is I don't have to worry about what's the biggest thing they have in common. There's really only one way to factor both of them, right? So it's even better than numbers. It's much more rigid. How do you factor x squared minus 4?
X minus 2 plus x plus 2.
Good. How do you factor this? X minus 2. X plus 6, bigger one positive to make the middle one positive. We're doing good so far? Okay. All right. So now, yes, ma'am.
And you give the...
Yeah, so what's he missing that he's got?
X plus 6.
He's got X plus 6. Okay, here, have an X plus 6. Just calm down. You got kids. I don't have kids, but I'm pretty sure that happens. Because I remember doing that to my kids. What does he need that he's got? X plus 2. Please let that be that easy. I mean, do you guys see that? I mean, if you're able to factor, most of this chapter should be easy. And the whole idea of LCD is to multiply them up so they both agree on something, right? So if you know exactly what he's missing that he's got, you give it to him. If you give them both what they're missing relative to the other one, they end up in the same place. Don't they have the same denominator?
Yes.
Yes, thank you. Not the most interactive, but that's all right. So on the bottom, what am I going to have?
X
X plus 6, X minus 2. I'm going to have the denominator, right? I'm not going to have them squared or something silly. 1/7 plus 1/7 is 2/7. It's not 2 over 7 squared, right? Don't suddenly freak out. Get the bottoms the same, and then that's what the bottom is. What do I have on the top now?
You multiply x plus 6
So I get x squared plus 9x plus 6. Can you factor that? Yes, ma'am.
So those two, the x squared plus 6 isn't in parentheses and 3x plus 6 is in parentheses. They're not two separate things, they're all one equation.
Yeah, it's just like 5 times 11 is 55. I don't have to keep it separate. I can put these numbers together now, right? So x times this is this, and then I'm going to add it to this. I can put my like terms together. The same way we combined 55 and 63 and got 118.
Oh, okay.
Yeah. So it's in parentheses here, just so I can see I've got to distribute, because it's x times this whole thing. The minute I'm done distributing, I don't need the parentheses anymore. They go away. Can I factor the top? Yes? Oh, okay. How do you factor it? Because I can't. Got to be careful. You need two numbers that multiply to be 6, add to be 9. So the 9 and 6 are not in the right place. Right?
Yeah.
Good. So you can't. I didn't do that on purpose, by the way. That is a little evil.
But usually, if you were to, is it common to get the answer wrong, where you get to that point and you can simplify?
Yeah, especially in the book. Especially that. They made a few of them so that it would definitely go a little further at the end. But not every single one, so don't go insane. Don't be too lax and go, that doesn't look like it's going to work. But don't think everything's going to work, right? Yeah.
Can you do that thing about 9 and 6 again? You said which has to multiply or what?
Yeah, so I know that in general to factor trinomial, I've got to get two numbers that multiply to be 6 and add to be 9. So if I look at this too quickly, I'll think 3 and 3 makes 9 when I multiply, but that's in the wrong place for that. Its middle term is the one that's got to add for that. Really easy mistake to make, trust me. I've certainly made the mistake before, being too optimistic. Thankfully, it's a long time ago, but still, that's not a hard mistake to make. Even if I made a mistake, could it reduce anyway? Nothing would cancel anyway, so I wouldn't even try to factor in the first place. It's the only reason I would factor is if something would die. Nothing would die, so why care? All right, so here, I want you guys to try something. Yeah.
I have a question. Why can't you flip them? Just because of the order?
I certainly could put that at the end. That doesn't subtly change how I factor things. The reason that this is the middle term is because it's got the x in it. It would be the thing that I would get from the middle two adding together, right? So just because I put 9x at the end doesn't suddenly mean, oh, I can now look at that as the thing I multiplied against. Because, so if I did that, I need two numbers that multiply to be 9x and add to be 6. Can't do that, right? The reason that if it was x squared plus 6x plus 9, that works because 3 times 3 is 9, and 3x plus 3x is 6x. So whatever has the x on it has to be the middle term. You can't just, I like that number better, let me put it at the end. You can't do that because of how it's going to get put together here. So that's why it's got to be in that descending order to see it. Yeah.
If we can factor it, like if there was a problem we could factor it, but nothing like would die if we factor it, can we just leave it?
Yeah, of course. Yeah, that's what I was saying. If you see it factors or it might factor, but nothing would cancel anyway, why do it? That's the only reason you would factor it. Yeah. Okay. So here, you guys try these. Take some out of the book here. Yeah, let me throw you some curveballs here.
this one we have. You can put it on that. Like this one I have two separate,
Good.
this one already has a third.
He's got 1 3, but what's he got?
Oh,
He's
so
got
you
2
put
3s.
another, okay.
Yeah. See, now they both at the same time. The minute you put something in the bottom, you gotta do just
Okay.
yeah, that's what keeps it legal.
Alright, so it is the same number, you have to give it another one.
They have to end up being exactly the same. So if one has only 1 3, but the other has 2, you gotta give the first one another 3, so that they agree. They're the exact same. He's got 2 2s.
It's the same laser.
Oh, just. Yeah, yeah. Yeah. Yeah, you got it. Yeah. Yes, but you can't. Yeah, so they're gonna end up with 3 things in one. Yeah. Sure. No, it's not. It's only if it's to a negative power. That's what we put something in. So you gotta be careful about that minus. And then number 3, I get some really creative attempts. Yeah, yeah. always get the right idea. Yeah, this is good. So the only mistake is should be minus 3. That's the only mistake. So what do they, so something went wrong here. The middle term's got to be positive. So the bigger number's got to be positive. So now they have, it's got A minus 1. Now they have that in common, and you see what's in each are missing. That's the bottom and the top. Oh yeah, so it's like, how would you do 3/4 minus 2/3? Yeah, well, yeah, exactly. They need each other. You see, if I made x3, I get this. So they actually end up needing each other. Give them each the other guy. Yeah, exactly. Multiply each of them by the other. Okay, all right. So that's the right idea. Okay, cool. Right here, it's got to be 2. So one has got to be 2. Yeah. Yeah. This is the 3 that I did. The same thing up here is that negative has got to go through both. So the same thing, and that negative is in front of this whole thing, so it's got to go through both. That's right. Huh? Yes, it does. In fact, we factored the same exact thing earlier. All right, guys, let's take a look here. The first one, that t is almost not even concerned. They both have it already, so who cares? So between 9 and 6, what's the LCD?
18.
Yeah, 18. So what do you have to multiply in by? 2. So, I mean, you could break this as 3 times 3, and this is 3 times 2. So he obviously needs a 2, and I was explaining to somebody else, he's already got 1 3, but he's got 2 3s, so he needs 1 more 3. Right? So they each have to have exactly what the other dude has. So if one of them has only 1 3, the other has 2 3s, you got to give this dude 1 more 3. Just keep them all happy. Right? I was thinking about little kids running around. So what do you get there? You get 8 over 18t minus 21 over 18t.
13 over 18.
Negative 13 over what sounds like AT&T. Okay. Freaking me out. A little commercial every time I do a product. Or a crappy service. Anyway, so here, I have to break these up first. Technically, if you multiply him by that and him by that, you're not wrong. You're just crazy. That's a lot of stuff. Oh my God. I would not even want to think about it. So how do you factor? You need two numbers that multiply by 2 and add to be 1. Yeah, the bigger one's got to be positive. So a plus 2, a minus 1. Good. We did that one earlier today, actually. A minus 1, a minus 3. So they have the a minus 1s in common. And I'm not picking on anybody because it's all few people do this. You cannot kill the a minus 1s, right?
Because
They're across from each other, and it's not even multiplication, it's subtraction. So it's double reason why you can't do that, right? Plus, I would never say 1/4 minus 1/8. Oh, cool, I can kill a 4 and have a 2. No, right? And that's really what you're doing there if you try to do that. I know it doesn't look like it, but that is exactly the same problem, just where I know numbers, and here I don't know what the numbers are. So now I know that they have a minus 1 in common, so what's he missing? He's got a minus 3, and he needs a plus 2. Now the next thing to be careful about is that minus sign. It's minus 4 times a minus 4 times 2. You got to take that negative through. So if you have a plus 8, it's not quite right. So this would become 6a minus 18 minus 4a minus 8. Stop right there. You guys see that? When there's a minus in the middle, you've got to be careful. And one thing you could do for yourself, I don't know if you remember this, but if I have 2 minus 7, that's the same thing as 2 plus negative 7. You guys remember that? So what you could do is make that minus, plus and negative, and then that's obvious negative 4 going through there. Right? So you don't forget to bring that negative with you. Okay? I don't know what it is. A lot of my classes just don't give me anything down. I have no idea if you guys understand what I'm saying. Alright, so that's the top. And what's going to be on the bottom?
A minus 1, A minus 3, and A plus 2.
Yes. So how do I... now it's just clean up the top. What do I get? 2a. Now you can factor the top, but would it go anywhere? So screw it, don't do it. You get an a minus 13, and there's no a minus 13 on the bottom, so why do it? Right? So don't do it. Yes, sir.
So if I had a minus 13 over the...
And one of those was a minus 13?
No, so I can't.
Oh, what's up, sir?
But, like... Okay, never mind.
So you wouldn't be wrong if you had this. That's fine. Right, I don't know where all three of those. That's the same thing, so it's okay. So here, the big mistake I see people make, and I don't know if anybody made this, I didn't see anybody, but I see somebody just do that. Which is so desperately bad. Because if that was true, then 1/2 would equal 2/3. In fact, 1/2 would equal 0. Because I could just subtract 1 from the top and bottom. It's 0. You owe me $500,000. Well, it's actually 0. So, broken my thumb. Oh, crap. So, I don't want you to get your thumbs broken over a misunderstanding of math. Yes?
Can I guess what you do?
Sure.
Do you give each one
Yes,
that they don't
exactly. This is exactly the same situation. The one time that the LCD is just the two numbers staring you in the face is when the two numbers staring you in the face have nothing in common. So what I'm saying is if I had 1/3 plus 1/4, what's the LCD? 3 times 4, 12. Because they have nothing in common, right? But if I had 1/3 plus 1/6, the LCD is not 18, right? The LCD is 6 because they have a 3 in common. You guys with me?
Yeah.
Okay. So here, x plus 1 and x, they have absolutely no factors in common. You can't say that they don't both have an x. This does not have an x in it. You can't say, take your meds, Jeff, I see an x right there. This does not have an x in it. The same way that 5 does not have a 4 in it. Does 5 have a 4 in it? Like 8 has a 4 in it, right? I want to make sure you guys understand what I mean when I say these things. 5 does not have a 4 in it. I don't care that it's 4 plus 1. When I say in it, I mean a factor of it. Multiplies to be it. So this does not have an x. This does not have an x plus 1. So they need each other. Good. I was trying to play it up so I get some kind of reaction. Alright, so what do I give him? X. And what do I give him? X plus 1. Now they both have the same denominator, right? You guys see that? That's such a simple, little, tiny, nothing problem, but I see so many people add 1 to the top and bottom. I'm like, no, you can't do that. You can't add something. The only thing you do to the top and bottom of a fraction is multiply or divide. We know that. But when x is coming to play, we're like, everything changes. No, nothing changes. Nothing changes. So then what's this come? Realize you got to be careful there.
Minus 2x minus 2.
Good, minus 2. So I get x minus 2 over x times x plus 1. Is that cool? And of course nothing there cancels, so I know I'm done. So never multiply the bottom out, just so at the end you can see if anything cancels. Alright, good, good. Oh, good, yeah. I think we can leave. That's plenty. So we got up through 7-4 officially. So next time we'll just keep on going. Yeah, we will. Actually, we'll have a quiz. Let's do it. Don't beat her up. Last time we ended up at 10. What did I make extra credit? 11-2. So it was 10-3, 11-1, and 7-1. Those 3 sections.
When is gonna be?
Wait,
Thursday.
can you just make it Tuesday?
Yeah, please.
Please,
No.
please.
What?
Then make it Tuesday.
No, I didn't say that.
Please, you pay the credit.
Huh? Quiz. Yeah.
For lunch.
Tuesday.
Thursday. All right. This will teach you to keep up with your homework. So Thursday, if you're not ready for it, oh well. Get ready for it. Okay. I'm so happy I got that on camera.